Alright, so here we have binomial theorem, the A score. This is everything in which you knew before in one place. So whenever we are asked to find a particular power of x, what should we do? So if x is at the second place, then the value of r is equal to the required power of x. You can even expand completely, but we don't have enough time in our exam. So in this case, the required power of x is 2, and thus the value of r which we will take would also be 2 if x is at this, like in this. So our expansion will look something like this. Phi C2 is 10, 2 to the power 3 is 8, and x squared. This turns out to be 80x squared. Now, our second example. The required power of x is 3, and thus r is equals to 3, since x is at the second place. So, phi C3, no, wait, it's 4C3 in this case. I was just distracted. And 3 to the power 4 minus 3. So minus x to the power 3. 4C3 is 4, and 3 to the power 1, and minus, and this is minus x cubed. This turns out to be minus 12x. This is our answer. So what would we do if x is at the first? Then the formula for r which we need to apply is this. And that is the power of the bracket minus the required power. So for example, in this case, x is at the first place, the required power is 2, and thus r is equals to 9 minus 2 is equals to 7. Thus our expansion would look something like 9c7 x 9 minus 7 and 1 to the power 7. 9c7 is 36 x squared multiplied by 1, and thus our answer turns out to be 36x squared. Now for our second example, we have this thing. The required power of x is 6, the power of the bracket is 7, thus r is equals to 7 minus 6, and r turns out to be 1. So the expansion would look something like 7c6 x to the power, wait, r is 1, and this will be 7 minus 1, and we have minus 2 to the power 1. 7c1 is 7 x to the power 6 and minus 2. This turns out to be minus 14x. What would we do if x is both at the first place and also the second place? In such a case, there's no shortcut. We need to equate the basic binomial expansion, that is this, with the required power of x. The power of x required. Like for example, in this case, x is both at the first place and also the second. And we need to find the coefficient of x squared. So equating the basic binomial expansion means something like this. We know the power of n. No, we know the value of n, so it's 8. C will remain as it is. We need to find the value of r. Then a. We know a, it's x, and we have 8 minus r, and then we have 2 over x. and to the power r is equals to x squared. There's, there would be something here, but the only thing we're concerned about for now is x and its power. So I can rewrite this as x 8 minus r, 2 to the power r, x would come up, and thus it would be x to the power minus r. Since we're only concerned about x for now, we'll deal with the x's first. So 8, these x's multiply, thus we'll add their powers. 8 minus r plus minus r, or rather just minus r is equals to 8x squared. Using the laws of indices, we have 8 minus 2r is equals to 2. R turns out to be, thus we have our value of r. We can simply expand to find the coefficient of the required power of x. So 8c3 is 56, 8 minus 3, so x to the power 5, and we have this. Thus our answer turns out to be something like 448, 5 minus 3, since one x is in the numerator and the other is in the denominator, and thus we have 448 to the power x to the power. This is our answer. So we dealt with whenever x is at different places and we're asked to find a coefficient. And then we have, if a function is such that it is not a binomial but can be converted to binomial by applying the relevance. This means that what if we have a trinomial? We have three terms to some power, random power. It's not a binomial, but it can be converted to binomial if I apply some substitution. So in such a case, let x plus x squared be y. This whole thing be y. And there is a question which students often make, that what if we substituted plus we substituted 2 plus x as y. So this will just make a mess because you will have two variables now, y and x. Never do this. Never mess with the constant. Always deal with the variable. Thus, once we applied substitution, we have something like this. We need to apply till x square, that is till r is equals to 2. So we have phi c0, phi c1 and phi c2. Since y is at the second place, c2's, and phi minus 0, phi minus 1, phi minus 2, and here we have y 2, 1, 0. Solving this would give us 1 into 32 into 1 is equals to 32. Solving this would give us 5 into 16 into y is equals to 80y. Solving this would give us 10 into 8 into y squared, 80y. Thus, we have our first few expansions. So we can write this as 32 plus 80y plus 80y square plus other values, which you don't need to worry about since you only need to find the coefficient of x square. You only need to expand until x square. So once we have this, I'll just make all of this a bit smaller. So once we have this, I can substitute y back. So 32 plus 80 x plus x square plus 80y x plus x square to the power to the whole square rather. So 32 plus 80 x plus 80 x square plus 80 x square plus 2x cubed plus x to the power 4. We need not worry about these for now. So just ignore them. Ignore these. Since the power of x is greater than 2. So we have 32 plus 80x plus 80x square plus 80x, and thus our final answer turns out to be this. Oops, this is my final answer. Never mess with the constant, substitute the variable or anything with the. So our second last concept is, if the question is such that after performing a binomial expansion, we need to find the value of a certain the value of a certain value to a power. The value, that is the answer of something to a power. We'll apply the following steps. Like, for example, we need to expand this first and then use this to find the value of 1.2 to the power 5. So in such a case, we'll expand this first. We already did this thing's expansion above. I'll just copy this for now. Here we have it. Just a second. So we'll copy this, and this is what we have after expanding 1 plus x to the power. And we need to find the value of this using this expansion. This won't be so accurate, but yeah, it will work. And if the examiner has asked you to find the value of this using this, you must do it. Don't use your calculator to just simply find this. So first of all, we need to find the value of x. Just equate both these things. The 5's cancel out, and we are left with this. X turns out to be 0.2. Thus, simply, this was our first step, this was our second step, and our final step is substituting the value of x back. Yeah. So substitute the value of x into the basic binomial expansion. No, not the basic binomial expansion, the expansion of the bracket. And we have 0.5, 0.2 to the power 5. Solve this, simplify this, and you will end up getting 2.488. So we found 1.2 to the power 5. Leave this as your answer in three significant figures or whatever it is. So last and most important part, I'll say, is finding NCR without a calculator. This is more than a concept. This should be a skill, I'd say. So 5C0, 12C0, 7C0, and NC0. So 5C0 is 1. 12C0 is 1 and 7C0 is also 1. Thus anything to C0 is 1. Similarly, we have 5C1 is equals to 5. 12C1 is equals to 12. 7C1 is equals to 7. Thus anything to C1, anything C1 is n. It's the thing itself. Now we have 5C2. We have two numbers in the numerator and two numbers in the denominator. So 5 multiplied by 5 minus 1 and 2 multiplied by 1. Just count down. And this turns out to be 10. Similarly, if you have 12C2, so 12 multiplied by 11, 12 minus 1 that is, and count down, and this turns out to be 66. If you have 7C2, 7 multiplied by 6, counting down, and this turns out to be 21. Thus, NC2 would be n into n minus 1 over 2 into 1. Now, and this is also a very important skill when it comes to expansion of fractions and negative powers. So, if we have 5C3, we'll do something like this, and 3, 2, and this turns out to be 10. Similarly, if we had 12C3, we'll have 12 into 11 into 10, counting down 3 numbers in the numerator and 3 in the denominator. So 3, 2, 1. This turns out to be 220. So 7C3 is 7 into 6 into 5, 3, 2, 1. This turns out to be 55. And finally, NC3. So n minus 1 and n minus 2 from observation. This is universal. This is universal. And yeah. And similarly, we can derive a few more expansions. Like NC4 would be n minus 1, n minus 2, n minus 3. Now we have 4 numbers after simplifying in the numerator, and we need 4 numbers in the denominator. Similarly, in this case, we'd have n into n minus 1, n minus 2, n minus 3, n minus 4. And in the denominator, we'd also have pi numbers counting down, and this is what we have. And this is how we find NCR without calculator. And this is the end of binomial theorem, the A square. But not the end of the chapter, certainly. We still have to cover the major part in E2, expansion of negative powers and expansion of fractions.